Welcome to Lesson 7 of mySci Unit 23, Our Place in the Universe. In Lesson 7, students will answer the question, what makes a star seem bright to us? Students will use models to explore the relationship between the distance of stars and their apparent brightness, and to explain patterns of stars in the sky throughout the year. They figure out that some stars look bright because their relative distance to the Earth is closer than other stars. Other stars appear equally bright even though they are many times further away from Earth because they have high luminosity. Additionally, stars appear to move across the sky, and different stars are observed in the night sky throughout the year. These patterns are caused by the rotation and revolution of the Earth. In the engaged portion of this lesson, students will discuss what objects can be seen in the night sky, such as stars, what we know about stars, and why some stars seem brighter than others. Next, students will be put into small groups and provided with a ping pong ball and marble. Students will consider which sphere is larger, recording their ideas in their student journals. Students should provide evidence to support their answer. They should then sit facing a partner. One partner will hold the ping pong ball out in front of them. The other should hold the marble out in front of them. Then the student should pull the object near their face. They will consider which sphere is closer to them and which sphere appears larger to them. Students will then switch objects and repeat the process. They should recognize that even if an object is smaller, if it is closer, it appears larger than a larger object. In the Explore portion of this lesson, students will conduct an investigation to determine if bigger stars are brighter. Students will use flashlights to carry out this investigation. To begin with, students will gather in one spot of a dark room. They represent an observer on Earth. Students will observe two large flashlights that are the same distance away. Then they will make observations after one of the flashlights is moved closer and one is moved further away. Students should recognize that when the flashlights are the same distance away, they have the same apparent brightness. However, when they are moved, the flashlight closest to them appears brighter, even though the flashlights are the same size. Next, students will observe an LED flashlight placed next to the flashlight that is farthest away. Students should recognize that even though the LED light is smaller, it appears brighter than the larger flashlight. In order for them to have a similar apparent brightness, the LED flashlight would need to be placed further away, and the larger flashlight would need to be moved closer. In the Explain portion of this lesson, students will read the book Stars. This is a read-aloud book, and the read-aloud guide can be found in the teacher pages. This resource can be used to further develop students' explanations about why we cannot see stars during the day and what stars look like. They will also obtain information about the factors that affect a star's apparent brightness. For example, some stars appear bright because they are very hot, while other stars look bright because they are very big. Astronomers can use color in addition to brightness to determine what a star is really like. Students will also obtain information from a video resource. Students will use this information along with their observations from the Explore portion of this lesson to hold a discussion based on the following questions. What makes a star appear bright to an observer on Earth? What is the difference between luminosity and apparent brightness? And what is the relationship between the apparent brightness of a star and its distance from Earth? Students should understand that some stars look bright because they are closer to Earth. Other stars look bright even though they are much further away because they are extraordinarily bright, like the LED flashlight. In the Elaborate portion of this lesson, students will discuss if we always see the same stars in the sky or not. Students will then observe the virtual planisphere. To use this resource, you need to scroll down to the bottom of the viewing circle and click Use Location. Additionally, make sure the constellation lines and constellation labels are checked. You can click to observe how the night sky changes daily. Students should observe the stars appear to move across the night sky from east to west. You can also click the weekly and monthly changes. Students should observe that as the months change, where the constellations are located in the night sky changes. At certain points, certain constellations are no longer observable. In fact, if you observe a constellation from Earth tonight, it will appear to have moved westward by 1 degree within 24 hours. Therefore, over the course of a month, the position of the stars at a given time will shift by roughly 30 degrees. Students will use this planisphere along with the constellation list found in the Student Journal page to determine what constellations are visible in the night sky throughout the year. Based on the data, students should recognize that we do not always see the same stars in the night sky throughout the year. This is not because the stars are moving, it is because the Earth is revolving around the Sun. As this occurs, and the Earth is in a different position relative to the Sun, we are able to see different stars in the night sky. Next, students will observe a time-lapse video of the night sky, which focuses on how stars move over the course of the evening. Students should recognize that stars appear to rise in the east and set in the west, similar to the Sun and the Moon. This is because the Earth is rotating on its tilted axis. In the Evaluate portion of this lesson, students will complete a formative assessment. Students will analyze and interpret data on the brightness of stars in order to answer analysis questions. By the end of this lesson, students should have demonstrated that a star's brightness is determined by size, intensity, and/or distance.